So in this video, we are going to take a look at a couple of application problems involving integration by substitution. So we have the marginal cost in thousands of dollars for a company that is producing X air conditioning units is given by C prime of X equals 50X over 5X squared plus E. The company has a fixed cost of $15,000. Find the cost function. All right, so the fixed cost of $15,000, that's going to help us find value of our constant of integration C at the end. So in order to find the cost function given the marginal cost, we are going to take the antiderivative of that marginal cost. So the integral of 50x over 5x squared plus e. We are going to use substitution on this. We are going to let our u be. Here, the only thing that really makes a difference, we don't have anything raised to a power, we don't have anything inside another function as far as an exponent or a square root or anything like that, but we do have a fraction. And so that denominator is going to be our substituted quantity. So we're going to let u be 5x squared plus e. So du is going to be the derivative of 5x squared is 10x. E, without an exponent, without an x up there, is just a constant, and so the derivative of that is going to be 0. So our du is going to be 10x dx. Now, we've got a 50x, but not a 10x. I am going to go ahead and leave that x there because we have an x in our numerator multiplied by our dx. So I'm going to go ahead and leave that there and just divide by 10. So when we do our substitution, we've got 50 times x dx is going to become our du. And then that denominator is what we are calling u. And then we still have this 1 over 10 for our du. So our x dx is replaced with 1 over 10 du. We've got our 50 and we've got our denominator. So 50 divided by 10 is 5 times 1 over u. When we integrate that with respect to u, that's the derivative of the natural log. So going backwards, we're going to get the natural log of that absolute value of u plus c. And then we need to go back in terms of our x's, and so we get 5 times the natural log of 5x squared plus e inside the absolute value, and then we have our plus c on the outside. Now we have our cost function, but it has two variables in it. We want it to just be in terms of our x, and that's where our fixed cost of $15,000 is going to come into play. So if our marginal cost is in thousands of dollars, then our fixed cost is also in thousands of dollars. So what we want to do is, so our cost is in thousands of dollars. So our units here are in thousands already. So that means if our fixed cost is $15,000, that is telling us that our original function that we're looking for, c of x, when x is equal to 0, because fixed costs do not depend on any production level, so we're going to let the production level be 0, and then the only costs we're going to have are those fixed costs equals 15. Well, we know what c of x is equal to, so we're going to plug in x equals 0 and set it equal to 15. I'm going to go over here and do it. So our cost is 15 when x is equal to 0, so we'll get 5 times the natural log of 5 times 0 squared plus e inside the absolute value plus c. We are solving this for that constant of integration c. So inside the absolute value, 5 times 0 squared plus e, that's just e, and natural log of e is just 1. So what we get is 15 equals 5 times 1 plus c. So that means that our constant of integration there is equal to 10, and our cost function, we'll just plug that 10 back in for the c in our cost equation, so we get 5 times the natural log of the absolute value of 5x squared plus e, close our absolute value, plus 10. And that is our cost function. All right, let's look at another example. We have a population of endangered species is relocated. The growth rate of the population after it's relocated can be modeled by p prime of t equals 700t e to the negative t squared over 8, where t is years after 2020. So if there was originally 2,000 individuals relocated in 2020, what is the projected population in 2025? So this one's actually got a two-part problem. The first thing we need to do is exactly what we did on the previous one and find our population function, and then we'll figure out what it's going to be in 2025. So the first thing we need to do is find our p of t. So we're going to take the integral of our p prime, 700 times t e to the negative t squared over 8 dt. And our substitution here is going to be for what's in that exponent, the negative t squared over 8. And the derivative of that's going to be negative 1 over 8 times the derivative of t squared, which is 2t dt. And so if we clean that up, that's going to be a negative 1/4 t dt. And if we solve that, we've got a t and we've got a dt. So if we solve that for our quantity t dt, we're going to multiply both sides by negative 4, and we'll get negative 4 du equals t dt. So if we plug in our substitution here, we didn't do anything with that 700, it's out there at front. That t dt is what we plugged in, 4 times du, and then in the middle we've got our exponential e raised to what we called our u. So if we combine those constants, 700 times negative 4 is negative 2800, and the integral of e to the u is e to the u plus c. All right, let's go ahead and plug back in terms of our variable t. So our exponent is negative t squared over 8 plus c. So that is our population, or at least the form of our population function. We need to figure out our c, and in order to do that, we are going to use the fact that there were 2,000 individuals originally relocated in the year 2020. Well, t is years after 2020, so that is giving us when t equals 0, our population is equal to 2,000. So we're going to do the same type of thing we did on the previous example. We're going to plug in 2,000 for our population, and we're going to plug in 0 for our t and solve for c. All right, so if we plug in 0 for our t, our exponent is going to be negative 0 squared over 8, which is just 0, and e to the 0 is just 1, and so this is just going to be 2,000 equals negative 2,800 plus c. We can add 2,800 to both sides, and we get that c is 4,800. And so our population function, p of t, is going to be negative 2,800 e to the negative t squared over 8 plus our constant is 4,800. And then now we can use that to find our projected population in the year 2025, which is going to be when t is equal to 5. So plug in 5 for t. And when we plug in 5 for t there in the calculator, we get approximately 4,677 animals. So our population has grown, and I will see you guys next time.